So to conclude, the equations of circle can represent a real circle, a point circle, or an imaginary circle. Now, let's study two examples by using the formula to find the radius and the center of the following equations in general form. First, we have to find D, E, F, the three constants correctly. For this one, it's easy. This is D, this is E, and this is F. So, by using the formula, we can directly write center equal D over -2 and E over -2. So we got 3/2. For the radius, after we found the coordinates of the center, HK, we can directly use the formula h squared plus k squared minus f square root. So you will get 3.5. Of course, you can use the first formula, avoiding D, E, F to find the radius. For part B, for these equations in general form, what are the values of the constant D, E, and F? Are these correct? Okay, here, what we have to note. You find that for the coefficients of x squared and y squared, they are not equal to 1. So the first step, we have to rewrite the equations so that both the coefficients of x squared and y squared are equal to 1. We divide both sides of the equations by 2. And then we get both the coefficients of x squared and y squared are equal to 1. And for this case, we can find D, E, and F correctly. And finally, we can still apply the formula to find the center and radius. So for this case, the center is -3 over -2 and 4 over -2. So we got 3/2 -2. And for the radius, okay, still because we have found the center already, so we use h squared plus k squared minus f square root. After simplified, you got 2. Example 4, you are given the equations of circle in general form, and you are given that the radius is 1 unit, and you have to find the values of k. For this case, similarly, first, pay attention to the coefficients of x squared and y squared. Because they are not equal to 1, so we have to divide both sides by 4 for this case. And then you can find D, E, F correctly. So you are given that the radius is equal to 1. So you have D, that means 1 over -2 whole square plus E over -2 whole square minus f square root equals 1. Taking square on both sides, you got this. And by transposing the terms, we have k squared equals 64. And for this case, k equal positive or negative square root 64. So the answer is k equals positive or negative 8. Now, your turn. Please try quick practice 7.3. You can pause the video and do on your notebook. And after you finish quick practice 7.3, you can try to think further for these questions. Example 5. This is the last example of these sections. It is a questions from exercise 7a. Here we have to find the range of values of C such that the equations represent an imaginary circle. Because it is an imaginary circle, so we know that the terms under the radical size is negative for the radius. First, you have to check if the coefficients of x squared and y squared are both equal to 1. And for this case, it is okay. So, D, E, F are 6, negative 2, and C respectively. So we have the terms under the radical size of the formula of the radius is negative. We have D over negative 2 square plus E over negative 2 square minus F. This is less than 0. So we have 9 plus 1 minus C is smaller than 0. And finally, we got C is greater than 10. Now, okay, you have to try some of the questions in these sections to get you familiarized with the formula for finding the center and radius of the circle in general form. Please finish the daily exercise. Exercise 7a. These are some level 1 questions. These are some level 2 questions. And for doing these questions, you may also have to apply the formula you have learned in Form 3, midpoint formula. The tip to do question 8 and question 19 is you have to find first the center of the circle, and then you apply the midpoint formula. Try yourself. Do on your notebook and submit as PDF in this lesson.